Okay, I want to talk about something called an analysis of variance. And if you look in your Whit and Whit book on chapter 16, which begins on page 337, that's where we begin our discussion about that. Let me just kind of put in a nutshell what it is. Analysis of variance. I've made this statement several times that the amount of variance matters in terms of how the analysis goes. So, where analysis of variance is a type of analysis that's geared itself toward a particular certain kind of situation when you want to find out something specific, one particular thing specifically. One of the ways that we talk about analysis of variance, though, is that we generally don't say the whole term like this. We usually abbreviate it as what we'll just refer to as an Anova. It's an Anova. Now you'll see that chapter 16 is called analysis of variance parentheses one factor. So all we're going to talk about right now is what we might refer to as a one-way Anova. Sneak preview of coming attractions. Spoiler alert, next course, 7811, we'll talk about a two-way Anova. So for right now, analysis of variance and Anova, here's what it is. And you're actually already familiar with it. Let me give you a scenario based on some analysis from a procedure we talked about not long ago, an independent samples t-test. An independent samples t-test says that you're going to compare a mean from this group to the mean of that group. And it's independent because there's no overlap. If you're in one group, you're not in the other. What if, however, you've got not just two groups, but you have more than two groups? You have a classroom A, a classroom B, and a classroom C. Let's specifically say, let me just make up some numbers here. And we'll just call those classroom A, B, and C. And I've got a bunch of test scores. I'm just going to make up some numbers, 95, 93, 72, 87, 68. B is 88, 73, 94, 100, and C is 92, 85, 74, 83, and 85. Now, I've made these different size groups on purpose because to show you that if you'll remember back in an independent samples t-test, the groups did not have to be the same size. They don't have to be the same size for an Anova either. So somebody get out your slide rule and abacus and calculate what are these means. What is A bar, B bar, and C bar? Not the mean of that, and give me any, whichever one you get. And I don't know what they are, I just made the numbers up. A is what? 83 for A, okay. C is 83.8, I'm told. And B is, oops, oh no. Whew. Yeah, like X bar. I just call it A because we're talking about the A distribution. I've got a bunch of A scores. Okay, so B, I'm told, is 88.75. Okay, so my question is there any difference at all somewhere between the average of 83, 88.75, and 83.8? And that's what an analysis of variance will tell us. Now, however, there are two steps, or there are up to two steps, I should say. I can look at statistical significances, but only two at a time. I could do an independent t-test comparing A to B, and comparing A to C, and comparing B to C. I could do a bunch of independent sample t-tests and get essentially the same information I'm going to get here. Except there's a reason we don't do that. Because you remember that alpha level, or the p-value being our chance of being wrong? If I say there's a significant difference, let's say I get significant differences everywhere. There's a difference between A and B and A and C and B and C, although A and C are pretty close together, just eyeballing it. I've got 3 chances to be wrong. And that's kind of more, I'd rather have fewer chances to be wrong. So an Anova will let us answer in one fell swoop, is there a significant difference between at least 2 of the numbers? And we get a yes-no answer to that. So is there a significant difference somewhere? And if there's not, you're finished. But if you get the answer to the question, is there a significant difference somewhere, and the answer is yes, then there's a follow-up question. Okay, where? If there's not the first part is there a significant difference somewhere, and if the answer is no, there's no reason to look for where it is because you already know it's not. It's kind of like this. You're walking down the street and you come up to a stranger and you say, "Do you know what time it is?" If the stranger says no, the conversation's over unless you want to talk about something else. But if I ask, "Do you know what time it is?" and the person says yes, what's the follow-up on that? Okay, what time is it? So the first question says, "Do you know what time it is?" And if no, then we're finished. Is there a significant difference somewhere? No? Okay, we're finished. Is there a significant difference somewhere? Yes, there is. Okay, where? Do you know what time it is? Yes, I do. Okay, what time is it? So up to 2 steps. If the answer to the first part's no, you're done. If the answer to the first part is yes, then it requires some follow-up. Actually, this kind of came out pretty good. Let's pretend that I asked the question, and I've run the analysis, and I find out that there's a significant difference somewhere, and I start doing what we call follow-up analysis, or post-hoc, which means follow-up or after the fact. We do a post-hoc test because I've got to get the answer to the first question is yes, so I've got to answer the second question. And let's say I find out that B is significantly higher than A, and B is significantly higher than C. But A and C are not significantly different. That's the kind of information I find in a follow-up test. Or it might be that all 3 are significantly different from each other. How many ways can I get these 3 averages paired together? And I've already named them. I can compare A and B, I can compare A and C, I can compare B and C. So in my follow-up, I have to look at all 3 of those combinations. Now, a couple things we need to know about this is that there are 2 kinds of variances that we're talking about. We're talking about variances between groups and we're talking about variance within groups. Likewise, there are 2 different kinds of degrees of freedom. There are degrees of freedom between groups, and there are degrees of freedom within groups. Let's go back and we'll point out what those are. So, in this case, the degrees of freedom, didn't leave myself room to say this. The degrees of freedom between groups is 3 groups minus 1 is 2. 2 degrees of freedom between groups is just simply the number of groups minus 1. Yep. Degrees of freedom is still something minus 1. That's between groups. the degrees of freedom within groups, and here's where I need more room to write. Degrees of freedom within is going to be, how many degrees of freedom do I have in group A? 1, 2, 3, 4, 5 groups, so 4. It's going to be 4 plus, how many degrees of freedom for B? 3 plus, so 1, 2, 3, 4, 5 for C. It's going to be 4 degrees of freedom. So there are 11 degrees of freedom within groups. You can also get this by saying the overall total minus the number of groups, kind of like we did for the particular kind of t-test. It's exactly the same. The reason you have the other kind of degrees of freedom, because, and that's the degrees of freedom between groups, is because you've got more. You might have more than 2 groups. If you're just doing degrees of freedom between groups for 2 groups, like in a t-test, well, 2 minus 1 is 1. Not much reason talking about that. But if you've got more than 2 groups, so our degrees of freedom. So we're going to report 2 different degrees of freedom. Now, it's not a t-value. We talk about an F ratio, so it's an F value. So I'm going to say somewhere F of 2 and 11 degrees of freedom equals whatever the value is. Capital F. I think it stands for Fisher. It's a comma, just 2, comma 11. Yeah, I'll write better when I have more room. No, not really. You report both. So 2 different kinds of variances means you have 2 different kinds of degrees of freedom. Let's give an example. Let's walk through some things. What I mean by between groups and within groups in terms of variability, look at page 341. I've got examples A, B, C, and D. In A, I've got groups 1, 2, and 3, and I've got values of 8, 8, 8, and 8, and 8, and 8, and 8, and 8 everywhere. Think about what the mean is. What's the mean for group 1 in part A? Okay, you don't have to use your slide rule very much on this one. It's an 8. Group 2 has a mean of 8. Group 3 has a mean of 8. So is there any difference in terms of variability between groups? There's none, because everyone has the same mean. Group A is 8. Group 1's 8. Group 2 is 8. Group 3 is 8. How about within groups? Look at within group 1. Is there any variability within the numbers for group 1? No, they're all 8s. No for group 2, no for group 3. So in example A, there is no variability between groups, and there is no variability within groups. Well, that's not as helpful if there is a difference somewhere. So let's look at group 2. Example B, group 1, 2, and 3. Is there variability between groups? Yes, because the groups have different means. So there's variability between groups. But is there any variability within groups? No, because within groups all the numbers are the same as each other. Group C, and you may have to do a little slide ruling on this one. Is there any variability between groups? What are the means for 1, 2, and 3? Yeah, you got to figure this one out. Well, let me just tell you, they all have means of 8. Yeah. So they all have the same means. So there's no variability between groups. But is there variability within groups? Yes, because the numbers are not the same within the groups. D, and I'll save you a trip on following this. They all have different means. So there's variability between groups. There's also variability within groups. That's most likely the kind of situation you're going to have. You're going to have variability both ways. Variability between and variability within. So the question in terms of what is that variability, or how does the variability work into the analysis of finding significant difference? That's what the Anova does. Bottom line, an Anova compares the means of 2 or more groups. Having talked for 20 minutes on that, that's essentially what I said. An Anova compares the mean of 2 or more groups. You can do an Anova with 2 groups. You'll get the same significance as if you ran a t-test. Well, yeah, the question is, why would you? Some people never run an independent t-test. They just run Anovas all the time as a matter of course. There's no more trouble to do one than the other. So the only reason to do that is so you don't have to do a different kind of analysis, I guess. But I tend to run independent t-tests with 2 groups, and I tend to run. Well, you have to run an Anova if you have more than 2 groups. There's no such thing as a t-test for 3 groups. So an Anova will look and see if there's a difference between the means of any 2 of however many groups you have. And if you look at page 342, and it starts getting kind of nasty here. Do not pay attention to the calculations in the Whit book. But look at a couple of things, though. Look at the box on the top of page 342. It talks about the F ratio, which is exactly what I said. And that is, again, if I'm lying, I'm lying consistently. The F ratio is the variability between groups divided by the variability within groups. I don't care that you know what that is, but the difference in between and within is going to be most important to you when we're looking at degrees of freedom. No, the SPSS, the question was, do you divide something when you get an F ratio? And the answer is no, because SPSS is going to calculate the F value for you. Okay. It goes into all kinds of sum of squares and mean squares. Pay no attention to those things behind the curtain. Let's look at an example. I'm trying to find the best place for the data is given. I'm going to go ahead and just jump right into SPSS on this. I don't like that. Okay, look on page 348. I guess that's the best place to look at it. I wish I could show this to you and circle it, but I'm not going to. Okay, so look on page 348. Let me just let me just reproduce this. These are aggression scores. This is a fun example. Yeah, we're not going to actually carry out this experiment because one of you would just kill me before it's over with. Would not. So we're measuring aggression scores based on sleep deprivation. So hours of sleep deprivation. I have no sleep. One group was not deprived of sleep at all, 0 hours. Another group was deprived of sleep for 24 hours. Another group was deprived of sleep for 48 hours. And the aggression scores within each group were aggression scores for the non-sleep deprived people at all are 0, 4, and 2. The aggression scores for people who were sleep deprived for 24 hours are 3, 6, and 6. And we're going to, again, the higher the depth, the higher the number is, the more aggressive we're talking about here. So, saying that with fear and trepidation, the people who were sleep deprived for 48 hours had deprivation scores of 6, 8, and 10. Scores were a little higher. So what we want to know is I can eyeball this and see that the more sleep deprived the groups are, the higher the aggression scores are, but I don't know if there's a significant difference anywhere. I don't know if that makes enough of a difference to really get excited about. Now, I will say that groups of n equal 3, yeah, it's other than looking at an exercise in data analysis, this is not useful. That's not a useful group size. Again, kind of as a bottom line, I get a little nervous if a group size gets to be smaller than about 30. And I get, what's the technical term, dang nervous if it's less than 20. So, what's the mean? 0, 4, and 2, so the mean is going to be 2. Here, 24, 6 12 over 15 over 3. 5. 24 over 3 is 8. So my average deprivation score, just cranking these out of my hand, no sleep deprivation, the average aggression score is 2. 24 hours of sleep deprivation, the average aggression score is 5. 48 hours of sleep deprivation, the average aggression score is 8. Is there any significant difference between any of these means? And again, I don't know. We're about to find out, though. And these are what? They're separate people, so the groups are independent, yes. So I'm going to go to SPSS. I'm going to open up a blank file. Oops. And the way we enter the data, kind of like we do for an independent samples t-test. So all of our numbers are aggression scores. So when I go to variable view, I'm going to record an aggression score throughout the whole column. The other variable is sleep deprivation. Did I spell deprivation correctly? Now what I'm not going to do, I'm not going to worry about a value on this because here's something kind of neat I can do with this. First of all, let's enter all the aggression scores. Okay. Look at what my sleep deprivation categories were. They were 0 hours of sleep deprivation. I can enter 0. That's how much sleep deprivation they had. The next group of 3 was 24 hours, so I can enter 24. So I can put in a number of hours because that's what my category is. And then the last 3 scores come from 48. Sleep deprived for 48 hours. So I'm going to put in 48 there. So I have the data entered and recorded in the same, organized the same way as it is on page 348 of the textbook, but it's in the right kind of format here. Same information, but in a format that SPSS can use. So far, so good. We're all equally unhappy. Okay, why not? Oops. All right. Now, there are a couple ways to do an Anova. Let me take you through one particular way, which is going to look a little bit counterintuitive, but in the long run, you won't have to learn a second way. So let me tell you what you could do, but the way I'm not going to is we're going to start with analyze. Well, watch what I'm not going to do, but I'm not going to do it. So I'm just going to point to it. If I look at compare means, one of my options is one-way Anova. you can do it this way. And it makes sense to do it that way, and it's fine. But I'm not going to, because when we do a two-way ANOVA, I can't go that way. So I'm going to go the way I can always go. So I'm going to go to, and I don't know why they call it this, so before you ask, I don't know, general linear model. General linear model. And I've got a couple options over there. I've got univariate, multivariate, and repeated measures. I'm going to pick the univariate option. That's for a one-way ANOVA. If I were doing a two-way ANOVA, I would pick the if I were doing a multivariate ANOVA, I would pick the multivariate. But right now, multivariate has to do with if you have more than one dependent variable. A two-way ANOVA has to do with whether you have more than one independent variable. Right now, we just got one independent, one dependent. But I'm going to go to general linear model and go to univariate. And when I click on that, I'm going to get my window with the two boxes again. And I'm going to get the two boxes, the two boxes in the right part of the window I'm going to pay attention on are the first two. First of all, what's the dependent variable? That's usually the easiest one to get out of the way. That's what happens on the end of things. That's what you're measuring at the end. That's the aggression score. So I'm going to move aggression score into dependent variable. Now, here's another quirk of SPSS. The term for these purposes, in this context, the term fixed factor is pretty much the same as independent variable. So, and I should have pointed that out earlier when we were doing things for it asked for a grouping variable. A grouping variable is also synonymous for those purposes with independent variable. So fixed factor, again, I don't know why they don't just say independent variable, and we just have one of them. So that in this case, that's our sleep deprivation. Again, with the dependent variable being the easiest one to identify anyway, it's the other one. Let's look at, and I don't remember what some of these options are. Model, I'm not going to worry about model. That's next semester stuff. Oh, let's go to options. Again, a window opens up with two boxes and a bunch of stuff underneath. On the left box, it gives me only the dependent variable. And it asks me, of all those dependent variables you have, which ones do you want to talk about? Well, I've only got one. So I'm going to move sleep deprivation over to the right. Now look at the bottom options. There are a couple that are going to catch my eye. I'm going to click descriptive statistics mainly because I want it to tell me the means and standard deviation. That's not a default option that is automatically checked on. You got to tell it you want that. It's just as easy as punching a button, literally punching a button. But look what else it says. All of a sudden we have showing up. Thanks a lot for showing up late. Effect size. It calculates effect size for us. Well, why couldn't it do that for a t-test? I don't know the answer to that either. That's probably version 22 in a couple of years, yeah. So I want it to give me the effect size because I'm tired of doing this stuff by hand. So I'm going to click descriptive data, the descriptive stats, and effect size. My significance level is 0.05. That's the default option there, or default value. We're going to leave that alone. We like that. I don't think this says do anything else with it. So I'm going to click continue. Now, what if the answer to my first question is yes? Is there a significant difference somewhere? And I said that we've got to have an answer ready, or at least a way to get to the answer. So I'm going to have to look at the post-hoc. And again, the two boxes on top and a bunch of stuff underneath I see. The left box on top is all the dependent variables we have. And again, because with a big data set, you might have more than one, but we just got the only one we're going to talk about. So I've got to move that over. And as soon as I move it over, a bunch of options highlight me. I can make some more selections. So now all of a sudden I can punch other buttons if I want to. For right now, I'm still going to go with the equal variances assumed stuff. Remember we were talking about that earlier, so we're just going to go with that right now. And there are more of these than you want. Just for the sake of consistency, I'm going to pick the Tukey test. Yeah, I know. Well, there's Turkey and there's LSD and there's, yeah, I know, all kinds of stuff here. By the way, LSD stands for least squares difference, not what you think it is. So, good thing this stuff wasn't around the 70s, huh? Okay, so I'm going to select the Tukey follow-up test. You can select, and sometimes down the road we'll talk about reasons to make other selections, but right now, just kind of file that away as that's what we're going to do. So I'm going to, I'm not going to worry about the equal variances, although in Ingredient Cycle they take you through that, I'm not going to right now. So I'm going to continue, and I am ready to get an output window finally. And I've gone through this very slowly, but the Ingredient Cycle goes through the same step-by-steps, point to this, click that, hold your mouth this way, pretty specific. So I'm going to click OK, and as soon as I click OK, I'm going to get an output window. And voila, here it is. And I got all kinds of information here. Matter of fact, I've got more information than I can scroll through. Let's see how far I go down there. Okay, let's look at the first part first, as opposed to looking at the last part first, or the first part last. All right. In my descriptive statistics, which I asked for, remember I clicked that box that give me descriptive statistics? So right here, I have my mean for no sleep deprivation, 1 day, 2 days. And it's the 258 just like we calculated because the numbers were small enough we could do that pretty well. So I have means and standard deviations for both groups, or all three groups I should say. So part of what we're going to do when we write this stuff up is we're going to report means and standard deviations. Yeah, the question was, is the total thing we need to pay attention to? This just tells us there's 3 in each group for an overall total of 9. The total mean, that's the overall mean. It's not important for right now. Yeah, what that means is the overall mean is 5. Well, the 0 group is below that, the 1 day group is right on it, and the 48-hour group is above it. Depending on what you need to communicate in your write-up, you may want to refer to it, but it doesn't matter in terms of what it is as far as our analysis goes. Okay, the key thing for the first part of the question, phase 1, is there a significant difference somewhere, or vernacularly stated, do you know what time it is? Don't worry about the first part, but I want to know degrees of freedom, I want to know the F value, I want to know the significance, and I want to know, ooh, there's that eta squared. All right, now, I've got more than I can shake a stick at here, but let's see if we can unpack this a little bit. What do you know about degrees of freedom? And let's do this manually so we'll know what to pick out of the output window in the future to let it just kind of give us the answers. What are our degrees of freedom in terms of between groups? Again, so keep in mind we're going to write this sentence, F of how many degrees of freedom between groups? How many groups altogether? 3 groups altogether, so degrees of freedom for 3 groups would be 2. 3 minus 1 is 2. How about degrees of freedom for within groups? There's a total of 9 altogether. 9 minus 3 groups is 6. So 6. So my F value is going to reflect 2 and 6 degrees of freedom. The 2 is between groups, the 6 is within groups. And where that comes from is right here, the 2 and the 6. Now, here's something that's obvious and something that's not obvious.
If you look at the way those rows are labeled, the 2 is labeled sleep deprivation. That makes sense because we're talking about sleep deprivation. You got 3 different groups of sleep deprivation. 3 minus 1 is 2 degrees of freedom. The 6 is on the error line. I don't know why, but it is. Here's a good way to remember. It's the one that you think it is plus the next one. Now, for the F values, the P values, and the eta squared values, we look at the last one in the column. So, the F value for 2 and 6 degrees of freedom, respectively, is 7.364. The P value, P is equal to 0.024. Oh, does that tell us significance or not? A p-value of 0.02, and again, remember the p-value is the key to the whole dang thing. If it's less than 0.05, so what this tells us is that yes, there is a significant difference somewhere. So yes, I know what time it is. Conversation not over. So we got to scroll down to the post-hoc in a minute. Now the other thing, and don't worry about the word partial eta squared, but eta squared, again, it's kind of like an elongated n, and you can find this if you want to type this in your write-up. You can find this under symbols in Word. So eta squared is equal to 0.711, 711, and I don't know. I think that's and somebody correct me if I'm wrong, but I believe that's a large effect size. Okay, so in your write-up, and again, a sneak preview of coming attractions I'll go over before we end the session. In your write-up, you're going to have either 1 or 2 paragraphs. It's going to be 1 paragraph if there's not an overall significance. So the first paragraph is it's going to tell us this, but since there is significance, we're going to have to write the second paragraph. So you'll see 2 paragraphs if there's a significant difference. So right now, I've got, and I'm going to have to scroll down, so let me make a note of what this is so I don't forget. The F value for 2 and 6 degrees of freedom is 7.364, P value is 0.024, and eta squared is 0.711. So there's a significant difference. Okay, where then? We scroll down. Well, so far so good. Make sure I don't miss any questions over there. Oops, I cleared off my ink. Is there a question about what we're talking about? I cleared off my ink because I want to scroll down in a minute, but are we not ready? Okay, let's go on and look at the what time is it then, smart guy. I mean, have you ever called somebody and say, or maybe you've done this yourself? Do you know what time it is? Yes. Bye. I know. Some people like me would do that. Okay. Scroll down to, and if the multiple comparisons, or sometimes the output window will be titled something like pairwise comparison, so I may flip that phrase in, and even though it doesn't say here, but the multiple comparisons. Okay, so this is the post-hoc, the Tukey test. So now again, there's a fair amount of duplicate information here. We want to pick out the part that's not duplicate. I wish it wouldn't tell us things twice. I wish it would just tell us one time so I wouldn't have to decide if I already know this or not. I've got
three categories of sleep deprivation: 0, 24, and 48. Now, hopefully I'm pointing to those on your screen that you can see with my mouse. And on the first part, the 0 part, it compares 0 with the other two groups. The second part, the 24 part, it compares 24 with the other two groups. The third part, the 48 group, it compares 48 with the other two groups. So I'm comparing (0 to 24, and I'm comparing 0 to 48. Do I need to compare 24 to 0? It's already done. I don't need to do that. But I need to compare 24 to 48. Do I need to compare? The answer is no. Do I need to compare 48 to 0? Already done. Do I need to compare 48 to 24? No, because that's already done too. So when you've got three groups, you will compare the first group with each of the other two, and then the next group to go with the second one in that one. You'll see this pattern as we do a million of these. So I'm concerned with this line, and this line. Everything else I don't care about. Not that I don't care because I'm heartless. That's beside the point. I don't care because I already know. So, look at this column. Looking at that first line, I get a -3 here because the mean for 0 minus the mean for 24 is -3. That's the mean difference. Is that difference of 3 a significant difference? Well, look at my significance levels. No, 0.214. Remember what the means were? 2, 5. What was the 48 mean? Was it 8? Look, average regression score was 8. So is there a difference between the 2 and 5? No, not a significant difference. Let me do it this way. Two and 5, 2 and 8. I'm sorry. No, come on, Don. 0 and 24, 0 and 48, and 24 and 48. There's not a significant difference between the means for 0 and the 24 groups. How about between 0 and 48? The 0 here, the 48 here. My significant, or my p-value, is 0.02. That is a significant difference. So I'm going to check that one. So there is a difference between the 0 and the 48 means. How about between the 24 and 48? Again, my p-value is 0.214. No. So the only significant difference is between the 0 group and the 48 group. Well, I knew that was going to be a difference because that's the lowest and the highest one. So if there's a significant difference, it's certainly going to be at least between the lowest and highest, but not between any other pairs. So when you go from 0 to 24, you don't make a significant difference. But when you go 24 to 48, you don't make a significant difference. But when you go all the way from 0 to 48, there is a significant difference. It's kind of like from here to there, it's not very far. From there to the next step, it's not very far. No single step is very far, but eventually those steps kind of mount up. And that's what's happened here. Okay, questions, thoughts, comments on this. Now, I drug this example way out because I meant to. Okay. You're glad I drug it way out. That's all we need to look at. Not going to worry about the homogeneous subset stuff right now. We'll talk about how to write that up after another example or two. I think what I want is I want to do one more example. I may ask you to do an example, and then I'll follow up and do that at the end. Then we'll talk about the write-up.
Okay. So we okay with this example? Anybody playing the home version of the game have an objection or questions? Okay. All right, let's look at, let me close this up. Let's open up Green and Salkin. Turn to lesson 25. It begins on page 183. And if you will call up the file lesson 25 data file 1. Lesson 25 data file 1. It will go with the scenario that begins on page 183. And the one we're going to look at there is the one entitled The Experimental Study. It's the first one that it goes over. So I'm going to give you a couple of minutes to get there. The questions couldn't find the symbol section on the version of Word. Anybody help with that? I'm told to go into font. Scroll down, it's one of the font choices. Symbols is one of the font choices. Okay. Because the question was, follow-up questions, how do you find out where the edit squared is on the keyboard? And that's because you got about 27 different screens there. But once you find it, it'll always save that as a recently used one. So once you find it the first time, it helps you find it easier the next time. Right, once you're in symbols, yes. The question is there? Can you get a picture of the keyboard? And yes, I think there is. And I don't have. Let me see if I can find a word right now. I'll make something up. No, I've got it here. I'll find it here in just a second. Okay, yeah. Let me. I'll tell you what. Let me save that when we get the when we look at the write-up, the APA example. I'll try to find it there. Let's just go ahead and run these data right now. The scenario is, and I'll just talk through this as you find it. Okay. This is one of the, and we use this scenario a couple. This is the first of what I call our vitamin C example, and I want to compare what happens if you take either no vitamin C, a little bit of vitamin C, or a lot of vitamin C. And the way I'm going to figure that out is I'm going to see, and I'm looking at page 185. The mean difference is, the question is, does the mean change in the number of days of cold symptoms for the three populations? And my difference is the number of days with cold symptoms the second year minus the number of days with cold symptoms the first year. So what that means is, if I'm interpreting this correctly, our difference number, a higher number means more sick, more days sick. So you should have something on your screen like what I have now. This is lesson 25, data file 1. I've got three groups, group 1, 2, and 3. 1 had no vitamin C, 2 had a little bit of vitamin C, 3 had a lot of vitamin C. And they've spelled that out. They've defined it. They've labeled it as such and having that already set up. So the first person didn't have any vitamin C. He was sick 12 more days this year than he was last year, and so forth. Second group didn't have any vitamin C, but this person was sick 2 days fewer than last year. Again, more days means more sick right now. So I've got three groups. I'm going to go ahead and run the data if that's okay.
Say it again. A larger number here on the difference column means more sick than last year. 12 more sick days this year than last year. Just remember that a bigger number means more sick. So we're going to go to Analyze. And if you want to watch this, if you're watching this later on the recording, and you've not caught up with me, this is a good time to pause the playing of the recording and catch up. Make sure you get this stuff loaded and digested and everything. So we're going to go to Analyze. We're going to go to General Linear Model. I'll go a little quicker now because the steps are the same. Univariate. Click that. Opens up my window with a box on the left, a bunch of boxes on the right. The dependent variable is difference in days. The fixed factor is, again, synonymous with independent variables, the vitamin C treatment. Whether you got no vitamin C, a little bit of vitamin C, or a lot of vitamin C. Options, again, my group. I want descriptive statistics and effect size. I'm still going to do a 0.05, yes, for our alpha level. Okay. For the post-hoc, we're going to do the post-hoc based on, again, group, the only thing I've got over there to choose from. We're going to select the Tukey follow-up test. So some of the difference is just kind of as an aside or an insertion. Some of these are a little more conservative, some are a little more aggressive than others. It's possible to get something weird like I get an overall significant difference, but I can't find it anywhere. That's because if you get like really near 0.05 on one, you may have rounded down to get there, or it may have rounded down for you, and the others may have rounded up to get over 0.5, so you can't find it. So you just kind of try different things. Tukey is kind of a one with a sort of a good balance, though. So post-hoc test for the people divided up into groups. Tukey is our follow-up test. And we're going to click and we're going to say OK. And our analysis is this. Again, higher numbers mean more sick. So the placebo group, that was group 1, was sick an average of 3.5 days more this year than last year. The low and high dose were sick approximately 2 or a little more days fewer than last year. So to find out if there's any kind of overall significance between any two of those, I'm going to look at my test of between subject, and the key things I want to find here are from the degrees of freedom, the F, the significance, and the eta squared. From my degrees of freedom, again, the 2 and the 27. Where do you suppose 2 and 27 come from? There are 3 groups. That's where the 2 comes from. What? Between and within, yes. So the 2 is the between. 3 groups minus 1 is 2. The 27 comes from because we have 30 altogether minus 3 groups, or 9 degrees of freedom in each of 3 groups. So I'm going to write down somewhere F for 2 and 27 degrees of freedom respectively is equal to, again, the F value, and all these other values. We're going to look at the last number in the column, so that F value is 4.836, comes from right here. The P value, comma P, is equal to 0.016, comes from right here. And my eta squared, again elongated n squared, equal 0.264, which is either small, medium, large. I think that's, I'm not sure what that is. Well, I'll go back and look at green cycle in a little bit. See if that's small. Somebody may remember the scale. I think that's large, but I'm not sure. So it is. What does it take to be large? 0.4. 0.14, okay. So yeah, if it's over 0.14, it's a large effect size. And generally, you get a large effect size if you have a significant p-value. So because my p-value is significant, that's the most important thing here. It's less than 0.05. That means, hey, there's a significant difference somewhere. So the question is, okay, where? Well, we scroll down. I'm going to have to lose my ink layer on this. So we scroll down. You always ask for post-hoc, but if my p-value had been 0.06 or something, I just wouldn't need it. All right, so for my multiple comparisons, I want to compare the placebo to low dose, the placebo to high dose, and the low dose to high dose. Those are the only 3 lines I care about. Yes, it's always going to look like this pattern right here. Yep, it's always going to. Now, when you have 3 or 4 groups, or 4 or 5 groups, which we'll have some examples of those, you'll see the same kind of pattern, though. So, which of these, again, I'm talking about this line, and this line. Which of those are under 0.05? This number, not that number. So this tells us, and this is a good example to kind of put in plain English. This tells us that there's a significant difference between no vitamin C and a little bit. There's a significant difference between no vitamin C and a lot. There's not a significant difference between a little bit of vitamin C and a lot of vitamin C. So what this would kind of imply, and I say kind of because I want to soften the words a little bit, it kind of seems like it matters if you take some vitamin C, but it doesn't much matter how much. More is not necessarily better. Yeah. Yeah, if I look at the means, that kind of confirms what my eyeballs would have kind of told me. So let me go back up and tell. Because, yeah, it's good to keep in mind, it is the means we're comparing. These things right here. These 3 means. 3.5 compared to minus 2.10 compared to minus 2. Well, these 2 are pretty close together, aren't they? There's no significant difference. That's what you'd expect. But yet the placebo is different than both of them, which is exactly what we got. So take some vitamin C, or people who take some vitamin C are, what's the proper word, less sicker than people who don't. The placebo were the sicker. Didn't take any vitamin C. And again, this is an oversimplification because there are also a lot of factors that determine how sick you are or how long you're sick. So yeah, I like this example because it kind of confirms what our eyeballs would kind of lead us to think we believe, which is not always true because you can't always tell if something is significant just by looking at it or not, which is why we do the analysis. But the analysis this is pretty straightforward. It pretty much confirmed what we expected to find out, what we expected to conclude, so we did. Any other thoughts, comments, questions? I think, I don't know what I did. Oh, I took a screenshot. Didn't mean to. Okay, yeah. Okay, well, what I was going to say is, let's go ahead and look at the APA write-up for now, and if we have time, we'll go back and do an example, or let you do an example, or if not, we may save it till the next time. Let's go. Let me see if I can
find the APA write-up example. Thought I had this called up, but I didn't. Okay. And the reason I want to go to this is because this is based on the example we just did. So while this is in our minds, so if you look at the APA example for Anova, then you'll see this. Let me see if I can get this on the screen. I don't think I have it yet. Is it showing up on the screen at home? My monitor isn't picking it up just right. Okay. Okay, good, because I can't see it. Okay, so my research question is, and by the way, I was asked, do you need to include research questions on these write-ups? And I didn't say so, so I'm not going to say you have to. Matter of fact, this is the first time I've gone back and put the research questions, the null hypothesis on these examples. I did that just for you guys, but I'd like to see them, but I'm not going to count off anything if you don't. Besides, you're usually writing examples I'm familiar with anyway. Anyway. The research question is, are there significant differences between the change in number of days of cold symptoms between those who take no vitamin C, low doses of vitamin C, and high doses of vitamin C? The null hypothesis would be worded like, there are no significant differences between change in number of days of cold symptoms between those who take no vitamin C, low vitamin C, and high vitamin C. Again, the null is typically worded like the research question, except it's a negative statement. All right, so here's my write-up for this example. Notice I have two paragraphs. The first paragraph says, and we're going to pretend we had 300 people, not just 30 people here. A one-way analysis of variance was conducted to evaluate the relationship, and you can say relationship or difference here, between the vitamin C and change in number of days of cold symptoms from year 1 to year 2. The factor variable, the vitamin C, included 3 levels, none, low, and high. The dependent variable was the differences in days sick. The Anova was significant. And F of 2 and 297 degrees, that's the degrees of freedom between and within. The F value is 4.84, P value is 0.02. So I'm using the word significant. I get a p-value of less than 0.05, and I am rejecting the null hypothesis. Those all say the same thing. Those are consistent with each other. And then we talk about eta squared, and there's that eta characteristic. We say it was large, and we report what the number was. Now this is a good time to go back and say, I don't want to record it. If I want to find it, how do I? So if I go, I'm told to go to Insert, Symbols to the right here. Oh, up here, okay. And I get a, yeah, actually eta squared. The reason eta squared is here is because I've used it. So once you find it and use it the first time, it shows up at the beginning of your list. But if I had not found it, I've got to go to more symbols. I go to a whole bunch of different keyboard layouts till I have to find it, and I don't see it here. Yeah, actually, well, that's because it's recently used. And I can keep scrolling down and get new keyboard arrangements for all kinds of languages that we can't speak. Whoops. Okay, here it is, right here. So I can select that, and that will let me type eta squared. I can click insert, and it'll do that. So see how, actually I've done it twice. So I have selected eta squared. And by eta squared, so the way I do a square is I put a 2, I highlight it, and I superscript it. Go back to font and click superscript, which means exponent. So there's my, take that second one off. So now I put in eta squared. And I think I've got a slightly different eta squared than this one because I must have had a different font for it. Do it again, eta squared. So I'm going to go to, there's my eta squared. If I want to square it, I'm going to put a 2. highlight it. You can right click, except I lost my highlighting. There it is. You can right click, but I'm not going to do that. Go to Home and Font, and one of my options is Superscript. It's the same way. It's literally an exponent. If you type an exponent, and when I click OK, yep, there's my eta squared. Still questions? Still lost it? Hit home. Hit the home option. You're on home. So if you're home, oops, font's right here. Okay. Yeah, you may not be showing the same thing in your toolbar. Okay. 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 All right. Back to my write-up. Okay. So here's the sentence that we wrote telling us it's significant because, again, make sure I don't miss this, is significant. This is less than 0.05. We're rejecting the null. Because it's significant, we make comparisons. We make multiple comparisons. And you can use these same words to evaluate pairwise difference between the means of the three groups. A two-key procedure was selected, and what I say, there was a significant difference in the means between low dose and placebo. And I put my p-value to indicate how strong that difference was between the two groups. So these are significant. And also the significant difference between high dose and placebo, again, with the p-value reported again. Actually, I think one of these should have been 0.03 maybe. But no significant difference between the high and the low. And look at that p-value. I show an insignificant p-value. So now I'm going to move into kind of my plain English sentence and say, it appears that either a low dose or high dose, and you can say it however you want to, some vitamin C seems to be about equally effective. I'm a little bothered by the effective causal word, but that's okay for here. I'll get out of there. And I make reference to a table including confidence intervals. Now, I didn't point it out, but you notice that part of the output, I get confidence intervals. So I report those confidence intervals. So I've got columns of which groups I have, the no, the low, and the high, and the number in each group. And again, they don't have to all be the same. The means and standard deviations, and the confidence interval. Why do I have some blanks left in my because it's just repeat. I've got a column for placebo and low dose. I don't have one for high dose because I don't need it. So placebo and low dose is this. Placebo and high is this. Low and high is this. So that gets all three ways that we can compare the groups together. These are confidence intervals, yeah. And SPSS gives us that. You can copy and paste if you want to, but you're going to have to change headings and everything. And this table is just simply it's just horizontal lines and tabs. There's a table function of Word. I advise you to use that with caution a little bit because it doesn't give you the boxes the same size the way you want them all the time, and this you can kind of make it fit how much you want to use. It used to be, and it's changed now, and I know we're running short on time. Used to be that SPSS that APA did not let you use vertical lines. That's no longer really the case now. They're just kind of okay with that. So, so this is kind of the worst case scenario write-up. Actually, it's not. What if you have 4 groups? If you have 4 groups, you got more pairs. And that's okay, you can do that, and somebody will be bold enough to find something to write that up. I'm not going to tonight because we're almost out of time. What if we don't find significant difference up front? Notice I have a 1-paragraph write-up. So same research question in null hypothesis, but there's just no significance up front. So I don't have the follow-up test. So one way Anova was, and I'm describing things the same way, it's not significant, and the p-value is larger than 0.05, and we're retaining the null. Those all say the same thing. You can't say it's significant and give me a very small p-value and then reject the null. You got to say the same thing all 3 places. They have to be consistent with each other. So not significant is consistent with a p-value larger than 0.05, and that's consistent with not rejecting the null. And you can say the null hypothesis was not rejected. Notice typically I'm going to report eta squared. And in this case, I get a small effect size. Usually you get a small effect size if you don't have a significant difference. And my plain English sentence says, hey, that doesn't really matter one way or the other. I still have a table, but I don't worry about confidence intervals because I know that I already know nothing's significant, so I'm not going to worry about what the confidence intervals are. I still have a table, but I just simply report the size and means and standard deviations. Okay, the question was eta squared, what are the small, medium, and large numbers? Somebody help me look that up while I think I do, but I'm afraid to say. So 0.14 we said was large. Is it 0.1 and 0.6? I'm glad I asked because I was wrong. I was going to guess wrong then. So 0.01 is small. Well, we had 0.01. We said it's small. 0.06 is what it takes to be medium. And anything over 0.14 we're just going to call large. Okay, so for next week, and I think I'll say this other last example. If you want to play with it, that's fine, but I think I may say that, and we'll do it next week if we need to. I've pretty much drug out these ones that we've done a good bit, so that's fine. Homework is Chapter 16. This is Homework 10, Problem 16.11. It begins on page, the bottom of page 367. And this is a fun example too. The drunk example, we'll call it. Somebody called it. So the data, the scenario begins on the bottom of page 367. The data is presented to you at the top of page 368. And this is an example where you have 1, 2, 3. This is an example where you have 5 groups. Somebody's got to be brave enough to write this up as your APA example, and that's okay. If so, I may be a little more lenient in terms of missing the mark a little bit on something, kind of give you points for difficulty. So homework is 16.11, and an APA write-up based on the example we've gone over for the last few minutes here. And you can do any example except for the vitamin C example because that's already done for you. So you can do the one we did from the Whit book with the sleep deprivation, or you can do the homework example, or you can do the other example in Green and Salkin, which is the exercise lesson 25, exercise 2. I was going to do exercise 2 and not exercise 1. There's something weird. If you do exercise 1, which has to do with hair color introversion, the numbers come out a little. It's one of those borderline number cases. I'll just kind of skip over that. But you can do it if you want to write that up. So 1 homework problem, 1 APA write-up. Questions, thoughts, comments? In that case, then I will close the meeting and contact me as you need to.